Perfect. So, hi all. I'm Krishna Narasimhan, and I am newish postdoc with Professor Mira Mezzini's group, and I'm also involved in now handling and one of the people who's leading the efforts to guide the development of CogniCrypt. So, I'm essentially one of the guys taking care of CogniCrypt, right? So, I welcome you all for today's session, and so let's begin. So today's session, we will look at, before that, I add a small disclaimer that we're going to be recording this session, as most of you might be seeing, and we'll be putting it online. So if any of you want, whatever, you've said something so that you want to remove later, just keep me posted, but I don't think this is the case, right? So let's begin. Today we will see what is CogniCrypt, what is the motivation behind it. Many of you may already know about this, but still there's nothing wrong in brushing up at the basics here. And then once that is done, we will look at also how you as cryptographic task designers can integrate your APIs into CogniCrypt, right? So here is a rough agenda for today. First, as I mentioned, we will begin with CogniCrypt, the motivation. We look at how a user looks at CogniCrypt, how his perspective is, how a developer can gain the advantages of CogniCrypt. Then we will look at some basics behind what is required from your side as a cryptographic task or API designer to make sure CogniCrypt understands your tasks, so that the developers that use your API also get the same benefits of CogniCrypt that the current API users of CogniCrypt do. And then once that is done, we will look at a short demo with a rather synthetic API, a very small API. We will look at how we can design these components, which we first learned in theory in the previous part. And then for each of these components, we design them, we implement them, and then we will integrate this set task into CogniCrypt and see how it looks like, right? At the end of it, we'll discuss a part which is not related to CogniCrypt, but may be relevant to some of you so the context here is that CogniCrypt currently works only with Java. There is preliminary work on C++, but some of you also have your APIs in C or C++. So for this, you don't have to worry. It doesn't mean that you cannot integrate your stuff into CogniCrypt. It only means that you have to do one or two extra steps. And for those people, I will show you a technology called JNI, or Java Native Interface, which essentially allows you to link between Java code and C code. So essentially, it allows you to create an interface from Java side that faces your C code, or that is linked to your C code. Of course, the last part, we will not go into any details. There is plenty of documentation around, but I'll just introduce you to it so you get a flavor of how easy it is to actually create a Java interface for your C code, kind of like a wrapper. So this is the rough agenda. And I will take at least 2 breaks. So one after the introduction of CogniCrypt, the other after the basics of the integration, and final session will have the demos of integrator and also JNI, which is a very short demo, right? So this is how I'll split it. So which means for those of you who like, you can collect your questions for each session, and then you can just, during the break, you can ask me those questions. Or if you feel like something is fundamentally not making sense, please don't hesitate to interrupt me. If you feel like, okay, this is something, without understanding this, I cannot understand anything he's saying further, or if I'm speaking a bit fast or speaking a bit slow, please use there are some buttons there on your Zoom where you can raise your hand, or where you can say, go faster, go slower, whatever. But if you are struggling to find the buttons, and if it's an emergency where you have to ask a question, just unmute yourself and say something, right? So this is kind of the introduction of how this session will be. If this kind of made sense, if a few of you kind of say yes or raise your hands, it'll be quite okay. So that I know that people are still here, kind of like that things aren't broken, right? Would it be possible that some of you kind of raise your hands or click on the yes button now that you've understood how the session will go like? Okay, I got it from a couple of people, so I'm assuming that things are working fine. Okay, let's dive into first CogniCrypt, the motivation, and then what is the user perspective behind how to use CogniCrypt, right? So before we jump into CogniCrypt, I think all of you know that CogniCrypt is in the category of applications which can be called a security scanner, meaning it scans your application for security vulnerabilities and so on and so forth. But there is a primary difference between CogniCrypt and other security scanners. For this, first we will look at how most traditional security scanners work, right? The workflow of it. First, in the workflow, there is an API designer and a crypto expert who sits down and comes up with cryptographic primitives, tasks, and they design APIs to get access to these cryptographic tasks and primitives, like, for example, encryption, decryption, the algorithms behind it, so on and so forth, and they deliver an API, right? And then comes the software developer who might be developing a banking application, or he might be creating a service that is going to be used by the next rocket launch of NASA. He might want to, of course, make use of these cryptographic functionalities. For that, he will consume these APIs that was created by these guys, and then he will create his application or software or service to make sure that they are secure, right? Once he's done that, this app is then fed into a traditional security scanner, which is going to give you a very nice reporting. It's going to say, hey, this part of your code is less secure. This part of your code is more secure. I can see that inside your app, the encryption is not proper. The password is being leaked to some public server or some spy server in Russia, whatever it is, right? So something like this. So these kind of reports you get, and this is how the traditional security scanners come into the picture after you've built your app. And then it is ultimately consumed by your user, not the security scanner, of course, but the app, right? So this is all fine, but there is one important aspect of this that most security scanners are failing to acknowledge and address, which is where CogniCrypt comes into the picture. And what is this aspect, or what is this fact that needs to be acknowledged, is that the software developers you saw may or may not be cryptographic API experts. And unfortunately, as we will see in the next slide, cryptographic usages are kind of hard. Cryptographic API usages are hard, which means that these people need to be separated out, and the support needs to be provided for the software developer who's using the cryptographic API, right? So essentially, in the ideal scenario, a software developer is supposed to be thinking of high-level abstraction details like, okay, I have a password which I want to encrypt, I have a data which needs to be stored securely, etc., etc. And it's the cryptography expert or the API designer who needs to be worried about the more lower-level details like, okay, this is the algorithm you use, and these are the key lengths, etc., etc. And this separation of roles, so you may be lucky that sometimes a software developer is a really good expert in the cryptographic APIs and vice versa. But how do I put it? This difference is acknowledged by CogniCrypt, and which is why support for these guys are very important, so that vulnerabilities, especially the ones that are arising because of improper use of these APIs, are detected in advance, right? So let's look at an example to see why this is really hard, right? So as I said before, in an ideal scenario, a software developer is only worried about the high-level abstract details of that concern with his application, like how to handle user accounts, how to store payment information, how to encrypt secure data, and so on and so forth. But he's also forced to worry about what kind of encryption he must do, whether he must do encryption at all. If he's choosing encryption, what kind of key links are compatible with the particular encryption mode that he has chosen. So these are all the things that he's forced to worry about because the API usage demands him to, and he may or may not have the time for it, right? Because if you think about it in the life cycle, a software developer who's developing, I don't know, a banking module is not spending 100% or even 50% of his time thinking about cryptography stuff. That is just one part of the whole application that he builds, right? So let's look at a code example to see why this is really challenging, right? This is a simple example of a code where it's not even a full cryptographic task. The software developer is only trying to create a cipher object, and for this, he needs a key generator, right? And in the simple piece of code, I'll show you there are at least 3 points of 3 parts of the code where he can actually really go bad or really make mistakes. One is he needs to make decisions on what kind of a standard he uses, whether he's going to do AES, DES, or Blowfish and whatnot. And then he needs to make sure that his cipher object and the key generator object are using the same standard, right? In real code, this may be split apart in different locations. This is one place where he can go wrong. The second thing is once he's chosen the standard, he needs to make sure that the key length that he's choosing is compatible with the standard that he's chosen. So for example, 128 may be compatible with AES, but it's not compatible with other things, right? So this is one other place he can go wrong. And okay, you can argue that yes, these days we have good IDE support where someone opens Eclipse or IntelliJ, and then they press Control Space, and then they have all the possible options, and this kind of autocorrects it for you. This is true for detecting basic coding errors, but this is not true for avoiding API misuse errors, especially cryptographic API misuse errors. To drive that point home, let's look at a short example here. When he says cipher.init control space, he's getting like, I don't know, 10 different ways of initializing the same cipher object. Which one must he go for? What kind of parameters must he supply? And IDE support can only go so far as to tell you that, hey, in my opinion, 50% of the times this version of the init was called, but it can't guarantee that that is the correct way for your particular setup, right? So till this point, I hope I have driven home the one important takeaway, which is that unlike traditional security vulnerability scanners, CogniCrypt tries to help the developer who might make mistakes when trying to use cryptographic APIs, right? And this is not something traditional IDEs can support him with, as we have seen. And this is where CogniCrypt comes in, right? So now let's look at how the user can benefit out of CogniCrypt, and more importantly, how CogniCrypt is designed on a very high level. So first, let's understand how these traditional APIs or libraries are distributed to the developer, right? He gets what is called a functional interface. A functional interface is essentially just a bunch of objects, classes, and methods. And it says, okay, there's a cipher class, and the cipher class has 10 different methods, and each of these methods can have, I don't know, 15 a few kinds of combinations of parameters. And then voila, and then this is what the developer is presented with. What should he call first? How should he do it? How is this all going to relate to his cryptographic the functionality that he actually requires? For that, the only source of help for him, or the only kind of official source of help for him, is the API specification or the reference guide, right? So, okay, if you have your reference guide, why do you need CogniCrypt? Well, let's look at this reference guide for the Java cryptographic architecture, which is the most widely used cryptographic API for Java. The documentation is 64 A4 sized pages, and these are all primarily text assets, formatted text, but it's still text. He has to go through most of them for his simple task, which may be just 4 lines of 4 lines of JCA code. For this, he will have to spend a day, which he may or may not have. And even if after he uses them, there are plenty of studies which have shown that the documentation aren't always helpful, right? So this is how the traditional library is distributed to the software developer. And you can already see why this is. Of course, this is one of the rare APIs where there's documentation. There is not many APIs which even have documentation. You're supposed to just use the, the Java doc, or even worse, you just have to use the word of mouth to decide whether you're using the API properly or not. And then you have to wait for it to blow on the face of one of your clients saying that, oh, my data was not stored properly, and then you detect it, right? So these are not things that even are detected using compile time where your errors are generated. So as you can already see, traditional libraries, using them is problematic. Doesn't mean you can do away with these traditional libraries, or for example, the libraries that you are going to provide as custom cryptographic task designers, be it your wallet scheme or your post-quantum cryptography or whatever, right? So your APIs are presented as it is. What CogniCrypt is proposing is not to do away with these APIs, but present a more active concept of this library. What do you mean by active is that your functional interface still remains. The developer still uses the API as is presented. He just continues to write his code. But there is an evolving usage pattern, right? A usage pattern that kind of has the knowledge or the intelligence to know what is the correct way to use this functional API. And why is this active? Because these usage patterns are supplied, contributed, and evolved by the API designers or the crypto experts. If you remember before, CogniCrypt wanted to make, or is intending to make, the separation of roles very, very explicit, right? And this is where CogniCrypt is trying to make this separation of roles very, very explicit. And this is where the usage patterns is something that will be supplied by the cryptographic experts or the API designers or whoever has the knowledge on how to use your APIs. Now, what CogniCrypt does is it implements a security interface on top of these usage patterns. Essentially, the security interface is just an engine that reads and parses these usage patterns and then checks with the code that is written by the developer and says, hey, according to these usage patterns, you are not using your API properly. So this is what CogniCrypt presents. So instead of a simple library with documentation, what CogniCrypt provides is a library, but with a bunch of usage patterns that are evolving and contributed by the cryptographic experts, which means that these usage patterns are trustworthy, right? And CogniCrypt just trusts these usage patterns and then tells you whether you're right or wrong based on these usage patterns, right? So this is how CogniCrypt works. Now let's look at, as promised, the usage perspective. What does CogniCrypt provide to the end user, right? In the form of tooling. So what CogniCrypt provides, mainly it helps your, we've seen how it does it on a high level, but now we'll see what it provides. First, it helps you to choose the right algorithms and the parameters. Based on these usage patterns, it tells the user, hey, you're using it right, you're using it wrong, you're not supplying the right parameters, right? What it does provide after that is, this is only the case for when somebody already has a code that they want to verify. But what if they wanted to kind of start off on a fresh plate, right? So what if one of you designed a beautiful wallet scheme or a post-quantum cryptography scheme, and I want to know how to write the code, but I have no point of contact? In general, I would go to Stack Overflow or something to get it. But studies have also shown that in Stack Overflow or Google, most of the first searches always many times result in the wrong code, right? Especially with cryptography. This is really scary. So what CogniCrypt also allows is, it uses these usage patterns to generate the correct code. So you can just say, hey, I want to perform encryption using some specific quantum scheme, and then please show me how to do it. And then what CogniCrypt does is, it generates a beautiful template code, which will be a starting point, and from there you can continue to write your correct code. So because of these two provisions that CogniCrypt delivers to you, the helping to choose the right algorithms and writing the correct code, and also generating proper example code, CogniCrypt makes sure that you have integrated cryptography securely, and also you can continue to keep it secure in your code, right? Okay, so how is currently, so let's look at more specifics of how you can actually use CogniCrypt currently. There are many extensions being developed, but the primary way of using CogniCrypt is through Eclipse, right? You install Eclipse. Eclipse is a very popular IDE, probably second or first in many people's usage IDE preferences. And on top of Eclipse, all you need to do is you need to install CogniCrypt as a plugin. It's available online in the update sites, or you can just get the jars if you want to get the more new cool features, and then add it as a plugin. And then that's it. As a software developer who's using Eclipse, you don't have to worry about any of the details of what's going on behind, where the usage patterns are coming from, what CogniCrypt is doing. You just continue writing your code, and then you get all of the features of CogniCrypt directly in your IDE. So this is your primary way of currently using CogniCrypt, right? So we saw already that there are two primary things that CogniCrypt provides you with, right? So let's look at both of them from the user perspective, how it looks like. So the first thing CogniCrypt provides is a code generator, which essentially is a way for CogniCrypt to provide you with an example usage or example correct usage of your cryptographic API. The other is code analysis, where someone is writing a code and he gets actually some warnings to say, you're not using it properly, and this is how you're supposed to be using it, with some hints, right? Let's look at both of them with a short screencast of how it looks like from the user perspective, right? First, let's look at code generation. And before, again, we look at code generation, how is the user going to look at it? First, he will have to choose what cryptographic task he wants to perform at all, right? He has to say, hey, I want to encrypt my data. I want to, I don't know, I want to encode my password for secure storage, etc., etc. He chooses this task. And then, of course, once you've chosen the task, it's not just one particular way of encrypting data, right? For example, you might want to encrypt a string. You might want to encrypt integer. You might want to encrypt a file. So for that, the user is presented with a bunch of configuration questions, which are very high level. If you remember from before, one of the main motivations of CogniCrypt is to make sure that you don't, as a developer, you don't have to worry about all the nitty-gritties of your cryptographic algorithms or your API. So it's just going to ask you very high-level questions like, okay, what is the kind of data you want to encrypt, and so on and so forth. And then it generates source code for you from which you can start using your code. Okay, let's look at a short screencast of how it looks in practice, right? So here, this is how, so this is from an older version of CogniCrypt. The interface is going to look a little bit different now, but fundamentally it's still the same. First, he's going to choose, the developer has to choose what kind of task he wants to perform. Here we're choosing the obvious, the first task, the default task, which is encrypt data using secret key here. And then there's going to be a description. And then there is a bunch of configuration questions. You can say, hey, my data doesn't need to be so secure because I'm doing some gaming application, or I'm not using some banking application. And then he says, okay, where do you want to store your data? And then what kind of data you want to encrypt. And again, these questions are going to be very specific to the task you choose, right? So he's saying that, okay, I want to encrypt a string. And then he says next. And then it's going to say, okay, this is how the usage is going to look like. And then are you okay with this? And then once you say, okay, I'd like to generate code for this default algorithm in my Java project, and you say finish, it's going to generate two things. One is it's first going to generate a template usage where this is how you have to use your task, but it's also going to generate the correct usage of that particular task. In this case, encrypt. It's going to create functions which correctly, I'm sorry about that, which is going to correctly use this task, right? This is how you encrypt data correctly, right? So it's going to generate two things. One is your template usage. The other is actual task itself, right? So this is how the code generation works. The other part is code analysis. So how code analysis is presented to the user is rather live, and he doesn't have to do much. He just has to write his code and he has to save it. And that way, once he saves it, the change set is generated. And based on the change from a previous to current code, CogniCrypt is just going to check with the usage pattern and say, hey, the changes you've made are actually using the API improperly based on the usage patterns that I have. So here it is, it's wrong. So essentially, every time you say, the static analysis runs in the background and it presents to you a bunch of error markers to say it's a severe error, it's a not so severe error, and so on and so forth. So how does it work? Let's have a short demo of it. Here, of course, the algorithm is AES without supplying the blocking mode, which means the default blocking mode is ECD, which is considered insecure. So he's getting a cipher object, and then he's initializing the cipher and doing final, everything is fine. And he's going to invoke the static analyzer, and it's going to say, hey, the first parameter is AES, but it should be any of AES / the other secure blocking modes, right? So this is, and then once he says, okay, I'm going to provide a more secure blocking mode and a padding scheme, and then he saves it and invokes the static analyzer, and voila, the error marker is gone. So this is how, from the user perspective, the static analysis is provided to the user, right? So till now, what we have seen is we have seen how CogniCrypt, what CogniCrypt is for, who it is for specifically, how on a high level it makes sure that it is an evolving and evolving active interface on top of your very static interface, which doesn't have a lot of knowledge involved. And then we also saw how CogniCrypt is presented to the user, the two main components, which you will have to remember throughout the talk, which is the code generator, which allows you to generate example correct usage of your API. And then there is the static analyzer, which is going to tell the user, okay, you've written a code, it seems to be wrong. So these are the two main things. So this is a very brief introduction of CogniCrypt. before I get into how you can customize CogniCrypt for your APIs. So currently we have seen some examples of CogniCrypt that is based on the Java cryptographic architecture. But if you have your own cool API, how are you going to integrate it into CogniCrypt? We'll see that in the next session, kind of. For now, I'll probably take a few minutes break, 4 or 5 minute break. And in the meantime, if any of you have collected any. Okay. So till now we saw CogniCrypt. We also saw what kind of features it provides to the user. Now let's see how you, as people who have designed your own cryptographic task and your own cryptographic API, can get access to these features, right? How you can provide code generation functionalities for the user, how you can provide static analysis, code analysis for the users of your API, right? So before that, so this session will be split into two. One is a few slides on the theory of what is required by you to be contributed into CogniCrypt so that CogniCrypt understands your API, right? And is able to provide the two main features that we talked about. The second thing is, after this, we will see a short demo on using a small example API, how you can actually integrate, design these components, implement these components, and then basically applying the theory knowledge that we learned in practice. Okay, so for the first session, before I go into the three main components that are required for CogniCrypt to understand, let me kind of reiterate what were the two main components of CogniCrypt. One is the code generator, the other is the static analysis, right? The three main components in the order of importance are, the first is the Crycel specifications, right? Crycel specification. Crycel is essentially cryptography specification language, right? It's a specification language. It's I'll show you. It's not very hard to understand. It's not very hard to learn, but it's just the specification of the usage patterns that we saw from the previous section, right? This is the part where you tell CogniCrypt, hey, I have an API. I have a particular cryptographic API, whatever quantum scheme, wallet scheme, things like this. And this is how someone must use these APIs properly, right? That is what the Crycel specifications are for. And once you have your Crycel specifications, this is all you need for the static analysis part, right? If all you want is to provide your users with the code analysis support, you just write your Crycel specifications, put it in your project's build path, and then that's it. CogniCrypt automatically provides the static analysis support. So when someone is misusing your cryptographic API, he's going to get all the error warnings automatically. So the first part is the Crycel. First component that you need to provide to CogniCrypt is the Crycel specifications. The second component you need to provide are the Crycel templates, right? The Crycel templates are essentially just simple Java code, right? This is the correct usage of your API, right? So you would say, hey, if you want to perform a cryptographic task that my API provides, this is how the code will look like. But it's not just straightforward, just copy paste of the Java code that you provide in the templates. There is some dynamic part where you can link it to the Crycel specifications, right? You can use CogniCrypt to generate code for you. You can say, hey, I have these rules, generate code based on these rules. So your Crycel templates are essentially going to be just a blueprint where you say, my Java code is going to look like this in the blueprint, but inside the code will be generated based on the knowledge from these specification rules, right? Okay, so these are the two parts, the Crycel specifications and then the Crycel templates. The last part is rather very simple part, which is, if you remember from before in the small screencast of the code generator, you could answer some questions, and based on the answers to these questions, CogniCrypt would generate one or the other code. So you can say, my task is encryption, but I want to encrypt a string. My task is encryption, but I want to encrypt an integer. Right? For these scenarios, you need to provide if you have more than one variant of your the example usage, you need to provide CogniCrypt with some configuration questions, and you need to say, okay, based on the answers to these questions, generate one of these templates that are there, right? So it is what configuration questions are one way for you to tell CogniCrypt which Crycel template it needs to invoke, right? don't worry about it. These configuration questions need not be supplied from you in the form of a big text file or some JSON or XML or whatever. There is a very simple wizard. You just need to make the decision on what are the questions you want to ask and which question, which answers relate to which templates, right? That's all you need to tell CogniCrypt, and then CogniCrypt will take care of it automatically. There's a simple wizard where you can provide your questions, and then the type or the way it must look like in your code generation interface, and so on and so forth, right? Okay, so this is the very high level overview of what you need to provide. Three things. Again, I repeat, Chrysler specifications, Chrysler templates, and then the configuration questions. Once you provide these three things to CogniCrypt, CogniCrypt takes care of the rest, right? Your task is as much integrated into CogniCrypt as the Java cryptographic architecture is, right? And then you can distribute that version of CogniCrypt to your users, and then that's it, right? They are able to use your API securely and also integrated securely into their code base. Okay, now if you remember, I mentioned that there are three components in the order of priority or importance. I will go through them one by one in the same order. So first we'll look at Chrysler specifications. What are Chrysler specifications? How do you write Chrysler specifications, right? So, I mean, I hope, because I mentioned all these priorities, one thing conceptually to understand is all of the magic of CogniCrypt comes from the Chrysler specifications, right? As I mentioned before, CogniCrypt is an active library. It's not something where you have hard-coded. Most code scanners, you have hard-coded your rules saying, okay, these are the kind of errors, these are the rules, and then if it violates these rules, the code is behaving insecurely. But CogniCrypt relies on you, or rather the Chrysler specifications, to decide what is right and what is wrong, right? So that's why the Chrysler specifications are kind of the core of CogniCrypt itself, all right? Okay, so now before we look at how to write Chrysler specifications, let's revisit what are the kind of error messages. I'm getting a chat. Okay, so Johannes, you're taking care of answers, right? So, okay. So if someone wants to ask a very specific issue, a very serious question, just ask, unmute and ask, right? Thanks, Johannes. Okay, so let me minimize this. Oh, how do I minimize? Okay, so now, so before we learn how to write Chrysler specifications, we need to understand what are the kind of error messages that CogniCrypt supports, right? There are three kinds of error messages, so you don't have to remember a lot. And you have already seen one of them. The other two are kind of intuitive. You will see why. So the first kind of error message are the insecure parameter. You already saw an example of this, right? Where you create a cipher object and you say, okay, the standard is going to be AES, but the string currently only has the AES. It doesn't have the block mode or padding scheme. This is wrong. Why? Because the default block mode in AES, according to JCA, is ECB, which is widely considered to be unsafe, right? So this parameter is insecure. This parameter to the get instance function is insecure. The correct way would be to provide a blocking method and then also your padding scheme, right? So this would be the correct way of providing the parameter. Now, to summarize, this is the first kind of error message that CogniCrypt supports, where your parameter to a function is improper, right? It's insecure. It's not matching a particular string, or it's not satisfying some conditions, right? It can be some integer conditions, whatever, right? Okay, this is the first kind of error message that CogniCrypt supports. The second kind of error message that CogniCrypt supports is an incorrect call sequence, right? So an incorrect call sequence is when you are able to tell CogniCrypt that, hey, if you call this method, get instance method and init sign method of the signature, you need to update it with some data before you can actually sign it, right? So your call sequence of the signature object here is incorrect, meaning get instance init sign must be followed by something in between before you sign it. Or to put it a little bit technically, essentially it's just a state machine, right? So if you don't know state machine, don't worry about it. It's just a sequence of calls, right? So in CogniCrypt, you have a way of saying that, hey, first there should be a call to get instance, then there should be a call to init sign, then there should be like at least one call to update, but you can have multiple calls to update where you sign multiple data using the signature object, and then finally you sign it. So what CogniCrypt does in the background, it says, okay, my code had a call to get instance, my code had a call to init sign, but after this, it is directly calling sign, which is wrong because of the state machine that I have, right? So this is the second kind of error message that CogniCrypt supports, right? So first one was you being able to tell CogniCrypt that, hey, the parameter to this function must satisfy certain conditions. The second one is you being able to tell CogniCrypt that, hey, if you use this particular object, for example, the signature class, you need to call your methods in a particular order. And the third one is for a little bit more complex scenario where different objects must interact with each other. For example, here, if you notice, the init sign gets a private key object, right? A private key is another object of the same API. And we must be able to say that if you initialize a signature with a private key, that private key needs to be secure, right? So somehow you want some way of CogniCrypt to understand that the rules of another object are invoked and satisfied before you can call a particular method inside your object, right? So here you say, hey, everything is fine. Currently, let's say your code had updates, but still, let's say your private key size was wrong, right? In this case, 64 is insecure. You need to have something more than that. In CogniCrypt, you also have some way of telling how different objects interact with each other, right? So to summarize, before we go into Chrysler specifications, look at examples of Chrysler specifications. The three main things you need to understand are the three kinds of error messages that CogniCrypt supports. It supports ways to tell you that the parameters to your algorithms are improper. It provides you ways to tell CogniCrypt that your calls to your object, the methods are in the wrong order. It also provides ways for you to ensure that another object in some other class is created properly before you can create an object of this class where you have the rules for. Okay. So why were these three error kinds important before we go into the Chrysler specifications and how to write them? Well, because each error type each error type that you saw before corresponds to one section in your Chrysler specification, right? So you need to remember, so when you're thinking about when you're writing Chrysler specifications, you always think in terms of objects. You say, okay, this is one class in my API, this is another class in my API. You need to write specifications for each class. And when you write them, you need to think, okay, hey, are there any parameters that have some conditions within them? Are there some methods which need to be called in a particular order? Are there some methods here which require that another object is following certain rules? These are the three things you need to think of before you write your Chrysler specifications. Now, enough theory, let's look at an example of an actual Chrysler specification and how you can write. And for the sake of running example, let's continue to use the signature example that we just saw before, right? Okay, so every Chrysler specification has two parts, right? The first part is the metadata, where you collect information that you need for your actual specification. And the second part is the actual rules, where you write one section for each kind of error message that we saw before, right? So the metadata is quite simple. In the metadata, first you would say, hey, this Chrysler specification relates to this class. So every object of this class will be checked for rules you specify in this specification. And then the second section is you collect. So this is still the metadata, right? You're going to collect your objects. So these are objects which you will use later for your usage patterns, right? So don't worry about them, the details right now. You're just creating a few objects. Think of them, if you are more prone to thinking of them in programming languages world, think of them as global variables that you will use later in your functions, right? And the next section is events. This is again like objects, but here instead of collecting actual objects, you are going to collecting actual variables. You're going to collect methods, right? So here what you're essentially saying is that, hey, G1 refers to any call to get instance with one parameter of type string. G2 refers to any call to get instance with any number of parameters, but the first parameter is of type string. Right now, again, there are a little bit more nitty-gritties that I'm not going into for the syntax of Chrysler. I will link you after this talk to the real real full documentation of Chrysler specifications. But I'm just giving you a high-level overview and the main concepts of writing a Chrysler specification. Now coming back. First, okay, so in the events, you've said, okay, G1 refers to this kind of get instance, G2 refers to this kind of get instance. But in your rules, you may want to say, hey, all calls to get instance can be grouped using this aggregate, right? So in your events, you have the concept of creating method macros where you say each method of this particular look is referred by this name. But again, I can also aggregate or group G1 and G2 inside this one kind of basket called get instance, right? So this is where you create this aggregate baskets, right? Same with init signs here. I1 refers to any call to init signature with one parameter of type private key. I2 refers to any call to init signature with many parameters, but the first parameter is of type private key, right? And then you're creating an aggregate. So I'm stopping the signature objects event specification here. There is a lot more. You would have one for update, you would have one for sign, but let's, for the sake of simplicity, I'm stopping it here. So what the takeaway from this slide is that Chrysler specifications first begin with a metadata part where you say what class your specification applies to, what are the objects you want to collect, you'll see how we use them, what are the events you want to collect. So this is just collecting information. Till this point, you have actually not provided the rules itself, right? How you provide the rules are, again, very simple. As I mentioned before, just think of the three kinds of error messages that we saw. The first kind of error message was improper parameters. So you have a section called constraints where you say the algorithm, which you collected is of type string, for this call to get instance is in one of these three, right? There are other ways. So this expression algorithm in whatever, there are other kind of operators that you can use. You will see in the documentation later, but this is one way of saying, hey, my algorithm should be one of these two. And so every time someone calls a get instance with value that is not one of these three, he's going to get an error from CogniCrypt saying, hey, please choose one of these three. The second kind of error message that we saw was improper call sequence, right? For that, CogniCrypt provides you what is called an order section. In the order section, you can provide the complete order as comma separated values. You can say, first, I need to have a call to get instance, which means it has to be one of these two. It should be followed by a call to init signs, which should be one of the other two, and then update and sign. But if you see here, there is a small plus, right? So this plus here is to indicate that there has to be at least one call to update, but there can be more calls to update. But get instance and init signs, there should be only one call, right? So when you don't specify any attributes to your methods in your order section, it means that exactly one call, and that's the order, one after the other. But when you say plus, it means that you can have one or many calls. There are a couple of other ways of annotating your methods. You can put a question mark or you can put a star. If you put a question mark, it means that this method is completely optional. It may or may not exist, right? And if you put a star, it means that it can be optional, but also infinite, or not infinite, any number of methods, right? So again, the documentation is available for Chrysler. I will link you to it after the talk. Okay, so two kinds of error message. We've seen two sections in our Chrysler specification, constraints and order, right? The third kind of error message was improper class composition. This is where things get interesting, because if you remember, every Chrysler specification is referring to one kind of one object of one specific type, right? So we need some way for other rules for example, in this case, we need the private key objects Chrysler specification to interact with the Chrysler specification for the signature object. For that, you would use what CogniCrypt calls predicates, right? A predicate is just something with a name and then a parameter object. Here you're saying that, hey, in order for me to create a signature object, this predicate generated private key must be ensured for the private key object, right? So the private key object that is being called in the init method needs to have this predicate satisfied. How is it going to satisfy this predicate? That will be done using this ensures clause. So ensure section, where for the specification of key pair, he would say, hey, key pair, once it satisfies all of these rules, that particular object will satisfy this predicate. So this generated private key predicate is how these two specifications are linked. So ensures is a way of saying that, hey, once I'm done creating a proper object of key pair, please tick this generated private key predicate, and then once it looks at the signature object, it's going to say, hey, I want to check if my private key was already initiated properly using the proper rules, right? So this is how you link two Chrysler specifications together using the ensures and the requires. Of course, signature object can ensure something else, which will be used by something else later, right? So to summarize in these usage rules, each section of these usage rules refers, so there are 4, but you can split it into 3, right? So constraints, order, and then the requires, ensures, predicate. Each section in this Chrysler specification refers to one error kind. Constraints is how you say your parameters need to satisfy certain conditions, parameters to methods. Order is a way for you to say, hey, the call sequence must follow this rule. It must be like so-and-so call after so-and-so call after so-and-so call. You can say some of the calls are optional, some of the calls are maybe many, whatever, right? And then ultimately, you also say, this is how my Chrysler specification interacts with other Chrysler specifications written somewhere else, right? So this is an overview of how Chrysler specifications are written, right? I know I may have put in a lot of information in front of you, but as long as you understood the essence of how to write Chrysler specifications, we are good. You will have proper documentation, and don't worry, in this session, we will see a demo of a Chrysler specification written for a much simpler API. I will show you the API. We will do a demo live, and then not live, it's recorded, but we will do a demo while we are coding the Chrysler specifications. We will see how to do it. There are good editors for it. It's not like you have to write it in text, right? There are good editors for Chrysler specifications inside Eclipse. You can and should are encouraged to use them. So don't worry if you've not understood every nitty-gritty of what I just mentioned, right? If you've got the essence, we are good to go. Okay, now, till now, again, a little bit of recap. We saw Chrysler specifications because we wanted to contribute to the CogniCrypt ecosystem, right? If I remember, there are now, once you've written the Chrysler specifications and you put it in your CogniCrypt, it already knows. Again, I'll teach you how to put it in CogniCrypt, but once you put it inside CogniCrypt, it already knows how to provide static analysis rules, right? But what if you also want to generate example code? For that, you need to provide at least one more component, 2 more if you want to provide more flexibility, but at least 1 more, which are the Chrysler templates, right? Which are just example code on how your template code on how your correct usage will look like, right? So Chrysler templates, the definition is here. They're simple Java code that reflect what the correct usage of your API is. And these things are linked to your Chrysler rules. How? We will see now. Okay, so again, this an overview here. How do you write Chrysler rules? First, as I said, Chrysler rules are just Java code, right? Inside your Java code, you need to decide what part of the code is static, which needs to be copied as is, and what part is dynamic. Dynamic meaning you just tell the there's an API called Chrysler Code Generator. You just tell CogniCrypt to say, hey, generate code based on these Chrysler rules, right? That's all. And then CogniCrypt takes care of the magic, right? You only tell it, these are the parts that need to be copied as is. These are the parts that you figure out how to generate based on your Chrysler rules. That's it you need to remember regarding Chrysler templates, right? Let's see a short example in a screenshot. Again, in our demo, we will have some good overview of it, right? So you don't have to go through all of the Chrysler rules here. Just remember it is for a particular class. It has a particular order here, and there is a constraint saying that the iteration count must be more than 1,000. That's it. Don't worry about looking into all of the details here, right? But how is a Chrysler template going to look like? As I mentioned before, there is a static part and the dynamic part, right? Here, the static part would be this bunch of code, which is copied over as is, and any code where you're calling this Chrysler Code Generator API will be dynamic, meaning you're instructing CogniCrypt to generate code based on the knowledge the rules provide, right? So this part is the dynamic part. So now the static part, it depends on you, how you want your correct code to look like. You can write whatever code is, whatever part of the code is needs to be copied over. But for the dynamic part, you don't need to remember much details, right? First thing is you would say, hey, get an instance of the Chrysler Code Generator and include. So there are only 3 actual methods you want to remember. One is include class, In an include class, you would say, hey, include the rules from secure random, include the rules from PBE key spec, which is here, include the rules from secret key factory, include the rules from secret key. So here you're saying that, hey, these are the 4 Chrysler specifications for which I want you to generate proper code. But if you remember, there was also these small objects you have. This is optional. You have an option to link your static part to the dynamic part using this add parameter function. You can say add parameter, for example, PWD, which comes from here into the password, right? So you're linking this PWD to this password. So it will make sure this PWD is supplied to the constructor call that is generated here, right? Same way for the salt, you're saying that, hey, link this salt to the salt of the Chrysler specification. That way, this salt will be linked to this salt, right? That's it. When you write your Chrysler template, you only need to say, hey, Chrysler code generator dot get instance dot include A, B, C, D rules. For these rules, make sure my static part is linked to the dynamic part like this. And then at the end, you have a way to say dot generate. When you say dot generate, it's just going to generate proper Java code based on these rules. And at the end, there is also some other static part, right? So because there are 4 different rules mentioned here, I've only given you one rule here. Let's just look at that part, how the code is generated, right? If you look at it here, it's going to generate a PBE key spec object. The PWD is going to be linked to the password here. The salt is going to be linked to the salt here. And then it's going to generate a proper iteration count. You've said iteration count must be more than 10,000. It's going to generate some random number more than 10,000, and voila, it's taken care of, right? But your order also mentioned that it needs to have a call to C1, and then it needs to have a call to clear password. So it will also generate a clear password later. Why has it generated after the secret key factory is done? That is because of the ensures and the requires. You don't have to worry about them now. But the main thing you need to understand out of this slide is how, on a high level, to create Chrysler templates. You've created a Chrysler specifications. Based on the knowledge from the Chrysler specifications, you create your Chrysler templates. And this is how your generated code will look like. So when a user goes in and says, hey, please, I don't know, please generate a proper use of this wallet scheme, and he presses the button, it will generate code based on this template, right? Now, those are the first 2 parts. Now, you can optionally organize your Chrysler templates for the same task. As I said before, for encryption, you might have 3 different versions of encryptions based on whether you want to encrypt a string, whether you want to encrypt an integer, file, whatever, right? And for that, CogniCrypt uses this configuration questions and the answers to these questions to decide which template to invoke. And you also need to supply that. So that will be the next part, where you have to think about your configuration questions, where configuration questions, as I mentioned to you, are ways to allow you to define multiple generation templates for the same task. And before you are creating these or supplying these configuration questions, think about what kind of questions you want to ask. Should it be a text box? Should it be a radio button? Should it be a drop-down box, right? And then you link the answers to generation. So you will create more than one template, one for string, one for int, one for file. And then using what is called options, which are just hints, you will link answers to templates, right? We will see a real example immediately after the slide. But before that, first I summarize what we just learned till now, and then I give a short break. So to summary, CogniCrypt, blah, 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 blah. We saw motivation, everything. But if you want to incorporate your API into CogniCrypt, you need to provide 3 things. One is the Chrysler specifications, which tell how to use your API, right? What are the correct ways to initiate parameters? What are the correct ways to call your methods? What are the correct ways the classes must be interacting with each other? Second thing was Chrysler templates. Chrysler templates are a way to tell CogniCrypt how to generate correct code. You say, hey, my correct code should have these rules invoked, and then CogniCrypt takes care of the magic by itself, right, using the Chrysler specification. And the third part is the much simple part. Just think about, if you want to provide more than one way of generating tasks for generating your task, just categorize them using questions and answers to questions, links to different templates, right? And we will see a demo just after this. But before that, I want to take a short break, look at any questions that have come up, and you also have an opportunity to ask some questions right now. Cool. So now the last session, right? Till now we saw about CogniCrypt. We saw how you can make CogniCrypt understand your API. In the last session, we will see a short demo using a simple synthetic API, how you can do this, right? Now, for this, it will look like I'm using a bunch of editors and tools here, but don't worry. Um, Ultimately, you need only two things. Well, it says three things here, but only two things. You need to have an Eclipse IDE for RCP, RAP developers. I'll link it after this call. I'll provide you a PDF after this call. I'll distribute it to all of you where all of the links will be there. The second thing is you just need CogniCrypt, right? So essentially, CogniCrypt is a plugin which uses Xtext. So Xtext is this framework which allows you to create editors for languages. And in this case, in this specific case, we have used Xtext to create our editor for Chrysal that you just saw. So you don't have to type it in text, right? You have good code completion and things like this. And then you install CogniCrypt and everything is fine, right? Again, as I mentioned, I will point you to the right resources or right links after the call. Maybe it may take a couple of days, but as you will see, we will have plenty of work before that, right? Okay. So now that we know what tools I am using, which is pretty much nothing, Eclipse with CogniCrypt installed, let's look at the demo, right? So before we look at the demo, let me describe what is the API that we will be using. So till now we saw some cryptographic APIs and how to write Chrysal specifications, how to write Chrysal templates. If I go ahead and create Chrysal specifications and templates for the whole JCA, it will take months or years, right? So that's not feasible right now. So let's create a simple API. The API has only two classes. One is a coffee class, one is a sugar class, right? The coffee class has a couple of constructors, essentially one constructor without any amount, the second constructor with an amount, and then there is one method to add sugar. And when you add sugar, you supply this object of sugar type, where you say, hey, and sugar class has only two constructors. One is a sugar without any value, and the other is a sugar with calories, right? Now, this is the description of the API to paint a picture of what we are going to be integrating into CogniCrypt, right? And let's have a couple of rules that we have in mind. Till now, the thought process is you don't know, you are not using CogniCrypt yet, so all knowledge or the rules you have in mind using text, right? You just collect your rules. You say that calories must be less than 1,000, right? Otherwise, the sugar is insecure. It's unhealthy, it's bad sugar, right? And amount of coffee has to be one of the two options. It has to be 10 or 20. So we can say 10 relates to a small coffee, 20 relates to a big coffee. That's it. And then the third part is the sugar needs to be, so the sugar that you're adding into your coffee should be healthy or secure or whatever it is based on the first rule. And I'm guessing you can already see a pattern here, right? That all of these rules can be encoded using Chrysal. So now next we jump into the demo, right? So first, I have created an API already, and then this API is distributed using this jar file, coffee_api.jar. It has two classes. Let's look at both the classes. The first class is sugar. Of course, there's a dummy method I have here for some small testing purposes. And then the second class is the coffee class, where you have your constructor. You have your constructor with an amount, and then you can add sugar. Right. There is also a stat method, which is just, again, for testing purposes. You don't have to worry about that. Now, the first task, as I already told you, is going to be creating Chrysal specifications for coffee and for sugar. Let's begin with sugar because it's the more simple class. As you have seen already, the first thing that happened was you right-click on wherever you want to create your Chrysal rule. You say right-click, new, and then Chrysal file, right? If you install CogniCrypt, you have this already inbuilt in your Eclipse, right? And then you would say, hey, I want to create a Chrysal rule for this class, d.coffee.api.coffee, which should match with your API. And then it gives a file name. There is an error message, which is bogus. You can ignore it. Then you create another Chrysal file for the sugar. You say d.coffee.api.sugar, and then it auto-generates a name for you, and then you finish. Now you have two Chrysal specifications, and as you can see, that it already has provided you with all of the things that are mandatory, all of the things that are optional, right? The optional things are commented. So let's create a rule for the sugar class. If you remember, the first rule that we want to create for the sugar class is that the calories must be less than 1,000, right? So let's go ahead and create that. But for that, first we need to collect our objects. So we go back into sugar.chrysal. We're going to say, hey, I need an int object. I'll call it calories, right? That's it. And then I need to create an event. So let me collect both of my constructors. There needs to be a sugar constructor, or there can be a sugar constructor without any parameter, and there can be a sugar constructor with parameter. If you notice here, I'm pressing Control Space, and it's pointing me to the variables that were initialized before. Then I'm creating an aggregate where I'm saying, my constructors can be either a call to M1 or a call to M2. Here it's saying that, hey, there is a syntax error here because your constructor, the aggregates should have the colon equals, not just colons, right? Now it's over. There's another error which I will fix very soon. That is because your int calories here is not ended with a semicolon. So as you can see, you have good, so the Chrysal specifications, you have good guidance to make sure you're creating the proper Chrysal specifications, which is not syntactically incorrect or unparsable, right? So, and then for the dummy test method, I have created an M3 method 2. This is just to test if my order section is also working, right? So that's it. So now I've closed it and it's over. And in the order section, I'll just have one rule, which is to say there should be a call to constructor followed by a call to some method, right? Which can be optional. So I can or cannot have this call to some method, which is fine. So it's not wrong to have it, but if you have it, it's also fine. Now we'll have only one constraint right now. The one constraint is that the calories must be less than 1,000, right? Let's look at it now. That's it, right? Okay, so 1,000, I close it, and my sugar rule is complete. Let's see if CogniCrypt already detects my sugar rule, right? So this was a test that I did before, which I'm deleting. I say new, I would create a normal class which uses my coffee API. So test coffee API usage, I'll just call it that, the class. And then inside that, I will create one sugar object, or of course I need a method for it. So I create a method inside the, because if I need to call methods, I need to have, I need to be inside a method. I can't do it on the class definition itself, right? The global scope. So I imported my API, I've created a sugar object, everything is fine. Now let me create an improper calorie length, which is 1,200. It's going to run the crypto analysis. And don't worry, it's not going to take this much time in your machine because I'm running from sources here. It's taking a bit longer. It's a matter of 1 or 2 seconds. And then once you're done with it, you're going to have error markers here. It's going to say, hey, there is one error. And then it's saying first parameter, it's 1,200, but calories must be less than 1,000. So let's go and correct it. I say 900, I save it, and then I invoke my crypto analysis or the CogniCrypt analysis, and voila, the error marker is gone, right? So, and then the next, let's create a rule for coffee. Let's try to link both the coffee and the sugar rules to make sure a proper sugar is added to your coffee, right? So let's begin by creating the objects we need for our coffee rule, which is going to be 2 here. 1, we need an object for the amount of coffee, and 2, we are going to need an object for the sugar. So let's go ahead and create that. So we create an object for the amount of coffee, right? And then we create an object for sugar a bit later, but let's collect the constructors. So first constructor is coffee, and the second constructor is coffee with a sugar. So we already need to create our coffee with an amount of coffee. You're going to see coffee, amount of coffee. That's it. And then you will aggregate both of them using a constructor coffee. I think it should be colon, well, it should be colon equal to, so the error will be fixed then. M1 or M2. So essentially you're saying that the constructor coffee is just a grouping of both the kind of coffee constructors, right? Now, let's create a method for add sugar. We're going to call it add sugar, but we need a sugar object here. We don't have it. So let's go ahead and create it in the object section. So here you're going to say d.coffee.api.sugar, sugar object, end it, and then you can supply the sugar object here. That's it. Beautiful. Now, that's it. And then we are also creating, as I said, the test one, the some method, stat method, which calls nothing, right? This is just to test the order. We don't have to worry about it. Right? At all points, if you notice, I'm just clicking on these methods to show that these methods are actually linked to the real API, right? So you can go and check. There is a code completion and referencing all the way. So here we are going to say, okay, my rule indicates that I need to have one constructor to call coffee, another constructor to add sugar, and then another call to an add sugar, and then finally it should be done with the call to some method. Now, as you remember before, I'm going to say my amount needs to be in either 10 or 20. There is an error here. That's because the amount is not a recognized object. So you have to say amount of coffee. That's it. And then, now the next bit is we need to match the sugar and the coffee, right? But before that, let's just test if the current coffee rules work properly. So I say new coffee, I don't know, 35, which is improper, right? And I'm importing the API, importing coffee class. Now, if I run CogniCrypt analysis, it's going to run here in the bottom, and ultimately it's going to throw me a couple of errors, right? Takes a couple of seconds. As I said before, don't worry about it. It's not going to happen. So there's a couple of errors. One is first parameter should be either 10 or 20 for this call, and the second, you can double click on them and it'll actually take you to the line number which is causing the issues. Right? And it's also saying that, hey, coffee object is not completed. I am expecting a call to add sugar, right? It's not just that the first parameter is wrong, but the object should have a call to add sugar. So let's go ahead and add sugar. This was because of the order section, right? It's called sugar object. And then, okay. Now, but this is all fine. Our code is correct now, but we need to make sure the sugar and the coffee are linked to each other. So let's create a predicate called sugar created, and say that this specification sugar created ensures that sugar is created after the constructor is called, right? After you've called the constructor, so you also have some other expressions here. The documentation describes it completely. So you're saying that once sugar's constructor is called, the predicate sugar created is ensured. Now we can go ahead and say, this will be very handy also for the code generator to link the sugar object and the coffee object. So you're saying, hey, sugar has been created. Make sure that sugar created predicate is satisfied for this sugar object, meaning that before you add sugar, make sure that the sugar is created properly. That's all this predicate linking means. And then we leave it as is. Now let's go and fix this. Let's say it's a proper coffee. And then of course, we need to call stat method here. And then that's it. Your error markers will be gone once you save and rerun the CogniCrypt analysis. That's it. So while the CogniCrypt analysis is running, maybe let me show you one thing, that if you install CogniCrypt, you're going to have 3 new icons here in CogniCrypt. The last one is what we've been using till now, which is the CogniCrypt analyzer. If you save it, it automatically runs, but you can also forcibly invoke it if for some reason it doesn't run, right? The second thing, the E that you see refers to extension points, or rather when you want to integrate your cryptographic task. For example, for the coffee API, if you want to create coffee API code generators, you would use the E. And then the first one here is the code generator itself. So once you've integrated, you will see this in the list of options for the code generator. Now, till now, we have seen the Chrysal rules. We have made sure that the Chrysal rules for the coffee API are invoked appropriately and it's working properly, right? Now let's go ahead and integrate the task generator or the template code generator. But before that, as I told you before, you need to do 2 things. 1, you need to create the template, the Chrysal templates, and 2, you need to think of questions when you have more than 1 version of your code that needs to be generated. So first, let's create a simple Chrysal template, right? regarding the Chrysal template, when you're creating it, as I said, it's just a Java code, but there is a couple of things you need to remember. One, you need to decide on a name for your task. Here, I'm just saying it's test Chrysal task, right? And then two, you need to decide whether there's going to be one version or two versions or multiple versions of your template. So here I'm having two versions. One is for the string, one is for the int. Doesn't have to make coffee sense, but just two versions of your code. So what you have to do is you have to make sure that the package follows this norms. Again, I'll provide you a PDF with the proper documentation, and dot the task name followed by the option, right? So all this is this template is the code that will be generated for the string version, right? And inside, there is only a few things. You have a static part, right? In calories, amount of coffee, and you have a dynamic part where you're saying you're invoking the Chrysal code generator, and then you're saying include the sugar class and link the calories in the sugar rule to this calories and link the amount of coffee in the coffee rule to this coffee, all right? And then you say dot generate, right? Then, yeah, I'm just showing you the rules just to make sure that the calories, these strings must match, right? The name of your rule, the name of your parameters, they must match. Apart from that, once you've matched everything, CogniCrypt takes care of everything automatically. You don't have to worry about anything. All right, so you've included a couple of rules. Now let's create one more, or I've already created one more template, not just for string, but for another version, int. Both of them are going to look the same. The only difference is for the string version, it's going to return a string, which is a dummy value. And for the integer version, it's going to return an integer, right? That's it. This is the version for integer. Now, let's integrate this. As I showed you before, once you've created your templates, once you've created your Chrysal rules, you go ahead and tell CogniCrypt, hey, I have everything I need for you to create a task in your code generator templates. So for that, you click on this button called button with E, saying it's an extension point. Then you make sure the name of this task matches with the name of the task that you've chosen before. It's test Chrysal task instead of test Chrysal. You can provide a description. Here I'm just saying, hey, this is a sample use of the coffee API, right? Properly. And then you can choose the Chrysal templates. You can say, hey, I have a couple of Chrysal templates, and then you decide on the names. You've already decided that the names are the string and int for the of what I call the options, right? So you say this template, the string template. I've chosen the wrong location. Just a moment. Yeah, runtime CogniCrypt, and then yeah, Chrysal templates source. Yeah, just you can copy them over wherever it's more convenient for you. You just say, hey, for templates for the string task, this is the template. And I'm going to make sure, so I have to just here say this is the string template, right? These are the options. This is how you have to remember this part, because that is what you're going to link to your answers later, right? When you create your questions. So you have a test Chrysal int, and then you say here it's int. And then after this, you can also provide an icon for your task. You can say, hey, my task, I want to, I can, so the version that you saw in the demo was an older version. Right now, you can also have an icon for your task. So in the code generator, it's going to say, I have a coffee icon. Once you click on it, it's going to generate the coffee APIs general code. So now, the questions, right? Here you have only one question to ask and two possible options. So I'm just choosing a radio button, right? So simple description, whatever you can give a description, and then you will add multiple answers, and each answer will correspond to a particular Chrysal template, right? So you can say, hey, the answer is, I don't know, is this string, is your coffee string, is your coffee going to be integer? And then you have to add your options here. You say string, and then you add another answer. Is your coffee going to be integer? And then you say int, and then during. So the only thing is these text must be matched, right? The string must match with the option you gave for the template before, then the int must match with the option you gave for the int before, okay? And that's it. Now you've generated your questions. So you don't have to worry about the next dialogue. That's not relevant right now. And then you say generate. Now you said generate. What has happened right now is CogniCrypt, along with its many tasks, right? There is many already existing default tasks like encrypting, password hashing, whatever. It has included your coffee task, right? let's go ahead and test if the coffee task actually generates the proper coffee code. So, okay, this, you have your description, you have your question with your multiple answers. Let's choose the integer version, and you have to say where you want your generated code to be copied over. You say source, and then once you say generate, it's going to take a couple of seconds, and then this code is going to be copied over, and it's going to generate a proper use of your coffee API, which we will see. So it's combined your rules and your templates to generate. This part was dynamically generated. It's going to say, hey, I need to have a sugar object that needs to be passed to the add sugar. I need to have the amount of coffee linked to this, calories linked to this, and then I need to have a call to stat method to complete my rule. And then it's going to generate a sample usage of your task, right? So let's delete it. Let's check if the integer version generates another variant of the code, right? That's why we created the question. So first we saw the integer. Let's read the string version. Okay, when I do generate right now, voila, it's generated the code for the other version of the code, which is for strings, right? That's it. So that's pretty much what you have to know about the integrator, right? So you need to create your, okay. So let me pause it here. Let me go back to the summary here. This slide is, yeah. Where was I? Yes. So this is kind of the end of the integrator demo. But what we saw currently till now is we saw that CogniCrypt has a couple of components, and to make sure your API is recognized by CogniCrypt and you can provide code generation support and static analysis support for your API, you need to create the Chrysler specifications, which is just a bunch of rules. We saw they're not that complicated. And then you need to create a Chrysler template, which is essentially Java code, which links to the Chrysler specifications to say, hey, my Chrysler template uses these rules. So CogniCrypt takes care and it generates the proper code for these classes, right? And then you can categorize your templates based on questions and answers, which is pretty simple. And this is optional, right? If you have only one version of your task, you don't have to worry about the questions at all. You just create the Chrysler template and it's over, right? And then we also saw a short demo with, we learned some theory about the Chrysler specifications and then the Chrysler templates. And then ultimately, we also saw a short demo with a coffee API, where we created the coffee API, we created rules for the coffee API, we integrated it using the integration wizard into CogniCrypt, and CogniCrypt automatically includes your task as one of its tasks, right? This is what we saw till now. So the last part of it is for those of you who do not have Java as your language with which you have created your Chrysler, sorry, not Chrysler, your APIs, right? Some of you here, so for those of you who have your APIs in Java, all well and good, you don't have to worry about this, right? For those of you who have it in C, which seems to be some of you in this call, or C++, there is something called a Java native interface, right? A Java native interface is just a way, it's not provided by CogniCrypt, it's there in normal Java support, where you are able to create wrappers for your C API, and this is then, these wrappers are then linked to your C code. And then what you need to do is, after you've created this Java native interface, you need to follow all of the steps that we just saw before for the Chrysler rules, Chrysler templates, everything, right? So the steps that you learned before remain the same. But the steps that you're going to learn are relevant if you have your API in C, right? There is only three main things that you need to remember when you're creating the JNI interface. There is a lot more, and there is really complex documentation for it. You can look into it if your APIs are complex, but the basics I will run through in the short demo and then this description. First, you need to create a Java class which corresponds to your C class, right? So make sure that it corresponds with the C library, and then you need to use a particular method to invoke your C library. We will see how, and then you will create native methods corresponding to every C method that you have. So for example, if your coffee API was in C and your add sugar was in C file, you just create a corresponding add sugar with the native clause in your Java world, right? Once you've created this Java class, you compile your Java class and you generate C headers. I will show you how. This is just a simple command. You just say Java H, and then your C headers are created. And then all you need to do is the C headers will create a function for your native methods. You just need to link it using a couple of keywords into your C functions. Okay. I'll not run into too much of this theory here. Let's just see a short demo, right? This is just to show you that it's not that complicated to create a Java interface, right? So you don't have to be worried if your API is in C. So let's look at a short demo. I've created already a pseudo version of the Coffee API in C. So let's look at it. I've just called it coffeejni.c. It just has an add sugar method, right? It's not a complicated one. I've kind of made it even simpler from the previous version. Then I'm going to create, as you said, as I mentioned before, the first thing you need to do is create a Java version of it. Inside this, first, of course, in Java, everything is a class. You need to create a coffeejni class. And then even if you're not Java experts, it's rather simple. You only need to create links from your class to your other class. So the interesting thing here is you have to create a static block. Essentially, a static block is to tell Java compiler that, hey, run this code before anything. So here you're saying load the coffee library, right? So the name coffee that I've given here will be the same name that I will give later when I create a library from my C file, right? I will show you that how. And then for every method, currently there's only one method, you need to create a native version. So I've created a private native add sugar. And then you don't need to have a main method to integrate with CogniCrypt, but I'm creating a main method to just test if my add sugar, native add sugar from Java is able to call the add sugar from the C code, right? So here I'll just have a dummy call to the add sugar in the Java code. Let's say new coffeejni.java or add sugar, right? So the only thing you have to actually mainly remember are these two parts. The static part where you create your, let me go back a bit. The static part where you say system.load library coffee, remember this name coffee that you're giving right now, which will be handy later. And then for every method in your C world, create a native method. That's all you need to do here, nothing else, right? So I'm just going to try to compile my file or coffeejni.java. There is a problem here because the method declaration has no return type. You need to say it's void or int, or make sure that the signature, or rather your method signature of your C code is matching with the method signature of your native method. So I'm just calling it native. Now I'm compiling the Java file. Once I've compiled, if you remember, we need to generate headers for the C file. So I just say Java H coffeejni. That's it. It's generated a new file called coffeejni.h. And this is where it's making my life very easy. I just go into the coffeejni.h. I will copy the method signature it has created for add sugar. It's going to do this for all of the methods you create. All you need to make sure is that I've just copied that method. Make sure that these methods call the appropriate methods that you need. For example, here in my C class, I go there and I copy over this method signature, and then I just need to give them some names. I just say, hey, this is going to be called, I don't know, JNIN, and that's going to be, because that was a signature, we need to give some object some name, but you don't even need to use them in this case, right? So, and then here I would just call this add sugar from this. That is how the link from the Java to the C methods are happening, right? And for me to have these signatures, I need to include jni.h, just like stdio.h, it's a header file that supports JNI in the C world. And then I need to include my actual header called the coffeejni.h, which was generated. And pretty much that's it. Now the linking is complete. I just need to create a library. One thing to look for here is this libcoffee.lib. So this statement you can just copy over. I will again send you a documentation for it. The only thing that you need to change here is the libcoffee.dilib, where you say do you remember I said system.load library, some library? That name must match here. And then you just say, this is the C file that links to this coffee library. That's it. Now the link is complete. My Java code can actually invoke the C code. Let's just see if that happens, right? So I'm just going to invoke my Java file, Java coffeejni. That's it. It has called the printf from the C world, and it has called sugar added. So this is just to provide you motivation to